Welcome back. So in the last video, we covered briefly the difference between traditional programming and machine learning. And again, I don't want to spend too much time on definitions. I'd rather you see this in practice. And I left you with the question, why would you want to use machine learning or deep learning? Well, let's think of a good reason. Why not? I mean, if we had to write all those handwritten rules to reproduce our Sicilian grandmother's roast chicken dish all the time, that would be quite cumbersome, right? Well, let's draw a line on that. Why not? What's a better reason? And kind of what we just said, right? For a complex problem, can you think of all the rules? So let's imagine we're trying to build a self-driving car. Now, if you've learned to drive, you've probably done so in maybe 20 hours, 100 hours. But now I'll give you a task of writing down every single rule about driving. How do you back out of your driveway? How do you turn left and go down the street? How do you park, a reverse park? How do you stop at an intersection? How do you know how fast to go somewhere? So we just listed half a dozen rules, but you could probably go a fair few more. You might get into the thousands. And so for a complex problem such as driving, can you think of all the rules? Well, probably not. So that's where machine learning and deep learning come in to help. And so this is a beautiful comment I like to share with you on one of my YouTube videos. Is my 2020 machine learning roadmap. And this is from Yashui. I'm probably going to mispronounce this if I even try to. But Yashui says, I think you can use ML. So ML is machine learning. I'm going to use that a lot throughout the course, by the way. ML is machine learning, just so you know. For literally anything, as long as you can convert it into numbers. That's what we said before. Machine learning is turning something into computer readable numbers. And then programming it to find patterns, except with a machine learning algorithm, typically we write the algorithm and it finds the patterns, not us. And so literally it could be anything, any input or output from the universe. That's pretty darn cool about machine learning, right? But should you always use it just because it could be used for anything? Well, I'd like to also introduce you to Google's #1 rule of machine learning. Now, if you can build a simple rule-based system such as the step of 5 rules that we had to map the ingredients to our Sicilian grandmother's roast chicken dish, if you can write just 5 steps to do that, that's going to work every time, well, you should probably do that. So if you can build a simple rule-based system that doesn't require machine learning, do that. And of course, maybe it's not so very simple, but maybe you can just write some rules to solve the problem that you're working on. Now this is from a wise software engineer, which is, I kind of hinted at it before, Rule 1 of Google's machine learning handbook. Now, I'm going to highly recommend you read through that, but we're not going to go through that in this video. So check that out. You can Google that, otherwise the links will be where you get links. So just keep that in mind. Although machine learning is very powerful and very fun and very excited, it doesn't mean that you should always use it. And I know this is quite the thing to be saying at the start of a deep learning and machine learning course, but I just want you to keep in mind, simple rule-based systems are still good. Machine learning isn't a solve-all for everything. Now let's have a look at what deep learning is good for. But I'm going to leave you on a cliffhanger because we're going to check this out in the next video. See you soon.